Okay, everybody, we're going to take a look today at Human Sciences Part 3 today. Okay, so this today is our third portion of our study in the human sciences. In a couple units, we're going to take a look at the natural sciences and comparisons between the two. But let's start today with a study of the word law as it applies to human sciences. Now, if we think of the word law in a scientific aspect, and we think about it in that sort of scientific method context, we have observation, we have measurement, we have experimentation. Those are all big parts of the scientific method. But the main goal to keep pushing science forward is to eventually develop some so-called laws, and then from those even theories to explain sort of the things that we are trying to scientifically analyze. However, when we place this in the context of the human sciences, we've got a bit of a challenge there. Like, how do we apply a law to, for example, economics or a law of psychology? Okay? One of the things that kind of stands in the way is this idea of free will, that humans have a free will that has a randomness to it, that contradicts the idea that laws can be even governed within human sciences themselves. It was actually Isaac Newton who once said that he could calculate the motion of the heavenly bodies, but not the madness of the crowd. So is studying humans too difficult to apply something as complex as a law? Well, there is still an element of predictability to humans. If humans don't have food, they're unhappy. Right? I know, for example, myself, if I get really hungry, I get grumpy. If the price of iPods goes up, people buy less iPods. If someone drops their lunch tray in the cafeteria, more often than not, after 16 years of teaching, I've seen it, a cheer comes out. Right? People cheer when that happens. There are a lot of generalizations we can make about human behavior every single day. And if human behavior was, in fact, completely unpredictable, why would we even get in a car and drive on the roads? It would be anarchy. So, something to think about. When you think of a person who you would consider an interesting person, do you prefer people who are predictable or unpredictable? Which to you is a more interesting feature? Human behavior makes most sense when it's explained in terms of beliefs and desires, not in terms of volts and grams. Okay, so the next thing is, let's take a look at sort of one of the laws that has been proposed in the human sciences, the law of large numbers. Okay, so what this states is that although individual behavior is really unpredictable, when we apply it to larger groups of people, that there is a certain predictability that we can kind of apply. For example, things like birth rate, marriage rate, death rate, okay? The law of large numbers says that if a population is large enough, the random variations within it tend to cancel each other out, creating a sort of factor of predictability. Okay? So for example, there's a lot of like customs and what sociologists call the norms within society itself that will perhaps affect the number of people who get married in a time frame. So we could say that bachelors are unlikely to get married, and engaged couples are more likely to get married within a certain time frame. So say we look at a 3-month period, and we look at all the people who are bachelors, pardon me, and within the same time frame, all the people who are engaged. There's more likely that the people who are engaged would have gotten married than the bachelors would have had some whirlwind romance and gotten married within that same time frame. However, there are random events. Sometimes bachelors will absolutely have that whirlwind romance where they meet someone and get married in a very short period of time. And similarly, people who are engaged will break it off right before they get married. Those certainly are events that do occur. But if a population gets large enough, those random events tend to cancel each other out and create a trend that we can kind of measure. This is the law of large numbers. It's more of a probabilistic law, that the probability of this event occurring is higher than it is not occurring in its nature. And this only occurs when we deal with large enough numbers, not individuals. Okay, so maybe I can't predict when John Smith is going to get married. I can't make an accurate prediction about that. But maybe I can make predictions about whether John Smith himself will get married or not. Okay? Are these probabilistic laws, however, just because of their probability nature, inferior to the laws that we associate with the natural sciences? Laws like gravity and laws of like motion and things like that. Okay? Well, I think you would probably agree that they seem to be less accurate than, say, some of the laws you learn in a physics class. But in fact, if you actually dig deep into those laws, like atoms and genes and motion, even those laws have a probabilistic nature to them, okay? Physicists can't necessarily predict the behavior of atoms in a more accurate way than a social scientist could predict the behavior of a man within a crowd. There is still a randomness factor even to those laws. We don't tend to view them that way, but they do have that sort of association with them as well. Okay. In carefully controlled laboratory conditions, animals do what they damn well please. So again, the general sort of consensus or the general impression that people have is that when dealing with humans and animals, laws are too erratic. They're too random. Okay, so let's use some different wording here. Let's switch our word to the word trend from the word law. Okay, so for example, there may not be any consensus about the exact size of the world population in 50 years' time. So if we're trying to predict what's the world population going to be like 50 years from now, it's more likely that they'll get it wrong as much as they might get it right. So for example, no one predicted the fall of communism in the 1980s from a economic standpoint. Okay? Another example, in 1973, an economist named Paul Ehrlich, or I can't properly pronounce his name, predicted that by 1990, 65 million Americans would starve to death. But in fact, what happened in 1990 is 65 million Americans were deemed overweight. So it is problematic when using these so-called laws, even the law of large numbers, to make predictions in the human sciences does not have a very good record. It has a poor record. Okay? So maybe we need to change the phrasing here. Maybe instead of the word law, we should identify what we would call a trend. Okay? That maybe human scientists uncover trends and not laws. A trend might show the direction that something is moving, but doesn't give explanation for that movement. Okay? So, classic example is something called the Phillips curve in economics. Designed in the 1960s by an economist named A.W. Phillips, it studied the relationship between inflation and unemployment. Okay? And it suggested that there was a relationship between the two. Meaning, like, as the rate of inflation goes up, the rate of unemployment goes down. And people tended to believe in this so much that they would act on this so-called prediction. So many governments then would essentially trade this off and say, you know what? We can lower unemployment by raising inflation, and vice versa. If we lower inflation, it will raise unemployment. But when they tried this, when they tried to reduce unemployment by letting inflation go up, the Phillips curve actually broke down. And for much of the 1970s, many countries experienced both a rising inflation and a rising unemployment, which was not something the Phillips curve would have predicted. Okay? And this is kind of a basic logical fallacy. You may remember we talked about fallacies last year. The basic logical fallacy here is called a post hoc ergo propter hoc fallacy, which means that just because we have two variables that are correlated, for example, means that as one goes up, one goes down, or as one goes down, or if they both go up at the same time, correlation does not imply causation, which means that just because they show that correlation does not mean that one causes the other to occur. Okay. We need more understanding of human nature because the only real danger that exists in man is himself. Okay, so now let's bring it together with the complexity of the real world that we are dealing with. Okay? This is obviously the difficulty, that the real world is very, very complex. It's much more complex than a simple natural science experiment. Okay? There's a lot of causal events that we need to untangle. Okay, here's the hypothetical. So I'm driving along a country road and I hit a wall. Now, I don't get hurt, but my car is completely destroyed in the wreck. What caused my crash? What is the cause of that event? Okay. Now again, we can look at causes in the natural sciences and think about things like friction and gravity and stuff like that. But what caused me to drive into a wall? Okay. Well, maybe there was a sharp bend in the road and it wasn't well lit at night. Maybe there was ice on the road. Maybe I was speeding. Maybe I had a few beers earlier that evening. Maybe I like to drive fast. And maybe my wife just let me and I was really, really upset. Okay? And maybe all of those things are true. So which one caused the crash? Because of the complexity of this situation, it may be impossible to determine which of them caused the event. It might actually be a combination of several, if not all of them, is part of the cause. And here again is the complexity of things happening in the real world. Okay? It's impossible to write this up mathematically like we do in, say, physics or math itself, which obviously has that nice nature to it. That we have the so-called proofs in math. We can't say, well, if X is true, then a car crash occurs, right? It's not that simple. It is much more difficult to kind of come up with these sort of things. And that's why it is hard when looking at things like teenage depression or smoking rates and stuff like that to try and nail down the cause. Like what is causing, for example, Manitoba students to do poorly in math? Well, there might be multiple causes there. Okay. So, although individuals can be unpredictable, law of large numbers says that we can look at, for example, trends in large enough populations. We can start looking at trends. Maybe not laws, but certainly trends. But when doing that, we have to be careful about trying to make the jump towards causation. We can maybe see correlation, but to jump to causation might be a bit of a hasty decision there. Okay? So, this doesn't mean we give up on it, though. Economics, for example, has tried and sort of started to build laws within their system. For example, the law of supply and demand or the law of diminishing returns. These are things that human scientists put into their studies, and it still makes it worthwhile. Okay, let's move on from here for today.